Bismillah ar-Rahman ar-Rahim. Today, inshallah, uh, we'll talk about transition elements and group number 8 in the periodic table. We'll talk about transition elements and group number 8 in the periodic table. Before I talked about group number 7, halogens, and about physical property and chemical property of halogens, okay, and about density, melting point, boiling point, reactivity of halogens. And we said in halogens group, uh, as you go down, reactivity increase. So that fluorine more reactive than chlorine, chlorine more reactive than bromine, bromine more reactive than iodine. And by going down through group number 7, boiling and melting point increase. Boiling and melting point increase. So by going down, reactivity decrease, and by going down, melting point and boiling point reactivity, melting point and boiling point increase. So about reactivity, by going down, reactivity decrease. Fluorine more reactive than chlorine, chlorine more reactive than bromine, bromine more reactive than iodine. And melting and boiling point will increase. Today, inshallah, we'll talk about transition elements. Then we'll talk about the group number 8. Transition elements. Actually, transition elements, as you see here, is the block of elements in the middle of the periodic table. About 30 elements in the middle of the periodic table. Okay, so transition elements are the block of 30 elements in the middle of the periodic table. They are all metals and include most of metals we use in our life, like iron, copper, and silver, like iron, copper, and silver. So here I have transition elements, about 30 elements on the left, on the right, or in the middle. No, in the middle of the periodic table, as you see here, with the yellow color. Okay, these elements are non-metal or metal. These elements are metals. Include what? Include most of elements we use in our life, like iron, as you see here, iron Fe, like copper, Cu, like zinc, Zn, like silver, Ag, okay, like gold, Au, chromium, Cr, and so on. Okay, so these elements in the middle of the periodic table, about 30 elements, include many elements we use in our life. So what about physical properties of these elements? What about physical properties of these elements? As we said before, these elements are metals. These elements are metals. So properties of metals, exactly properties of the transition elements. So it will be very hard, strong, high melting point, malleable and ductile. And when I'm talking about malleable and ductile, I need to refer to the following. Many questions in ISSE exams about malleable and ductile, especially in paper 4. You have to define malleable and you have to define ductile. You have to define malleable and you have to define ductile. Malleable can be hammered into different shapes without cracking. Can be hammered into different shapes without cracking. This is malleable. Ductile can be drawn into wires. So that if I ask you a question about copper, why we use copper to make electrical wire? Why we use copper to make electrical wire? Because copper is malleable. What is the meaning of malleable? Can be drawn into wires. Okay. Ductile, sorry, malleable can be drawn into different shape without cracking, but ductile can be drawn into wires. So we can use copper. We can use copper to make wires because copper is ductile. Because copper is ductile. Even these elements, good conductor of heat and electricity. Good conductor of heat and electricity. The best metal can conduct, okay, electricity is silver, then copper. So the best element is silver. The best element is silver. What about density? High density. So these elements, good conductor of heat, good conductor of electricity, very hard, high melting point, high density. Again, these elements, good conductor of heat, good conductor of electricity, high melting point, and high density. Now I am talking about physical properties of transition elements. I'm talking about physical properties of transition elements. Clear? But there is exception. I need to refer to exception about mercury, Hg. Mercury is a transition element, but the only metal is in liquid state. Okay, so mercury is exception. It's a liquid at room temperature. As we said before, all metals are solid. All metals are solid except mercury. Mercury is liquid at room temperature. Chemical properties of these elements. What about chemical properties of these elements? These elements when react, what about reactivity of these elements compared to group number one? Group number one, okay? Because these are metals, and these elements are metals as well. They are much less reactive than group one metals. Okay, I'm agree with you. These elements are reactive, but less reactive than group number one metals. So iron is reactive, okay. Even lithium is reactive. Which one is more reactive? Lithium is reactive. Copper is reactive. Nickel is reactive. Even sodium and potassium is reactive. So which one is the most reactivity? Sodium and potassium. So these elements less reactive than group number one. These elements less reactive than group number one. For example, copper and nickel do not react with water or catch fire in air. Unlike sodium, copper and nickel cannot react with cold water. Okay, cannot catch fire. But sodium can. Sodium can react with water, cold water. Sodium can catch fire. Number two, there is no clear trend in reactivity. There is no clear trend in reactivity. What does it mean, a clear trend in reactivity? What does it mean, a clear trend in reactivity? When I talked about group number one, we said as you're going down through the group number one, reactivity increase. So this is a trend. So reactivity of sodium more than reactivity of lithium. Reactivity of potassium more than reactivity of sodium. Reactivity of rubidium more potassium. Cesium more than rubidium. Francium more than cesium, and so on. So there is a trend here. By going down through the group, reactivity increase. Reactivity increase. The least reactive is lithium, the more reactive is francium. The more reactive is francium. Okay, so this is a trend here. But in transition elements here, there is no clear trend. I cannot say by going from left to right, from cesium to zinc, reactivity increase or decrease. There is no clear trend, so you cannot say that. But in group number 1, you can say that. You can say by going down, reactivity increase. You can say by going down, reactivity increase. You can say that. And here, in group number 7, you can say by going down, reactivity decrease. Reactivity decrease. So this is a trend. I have a trend in group number 1 about reactivity. I have a trend here. Even in group number 7, halogens, I have a trend here. In group number 1, I can say by going down, reactivity increase. But in group number 7, by going down, reactivity decrease. So fluorine is the most reactive. Okay, by going down here, chlorine is this, bromine is this, and so on. By going down, reactivity decrease, but in group number 1, reactivity increase. So this is a trend, but you cannot say in group, you cannot say in transition elements there is a trend. There is no clear trend in reactivity. There is no clear trend in reactivity, unlike group 1 metals, okay, and unlike of group number 7, non-metals, because these elements are non-metals. In group number 7, there is a trend, and here there is a trend also. Most of transition elements form colored compounds. Colored compound, okay, in contrast of group number 1, which will form white compounds. So these elements, transition metals, in the middle of the periodic table, when it will form compound, it will form colored compounds. Colored compounds. In contrast, the group number 1 metals form white compounds. White compounds. So if I ask you a question, I have oxide with a green color, oxide of a green color. What do you think? This oxide of group number 1 metals or oxide of transition metals? I see the green color, oxide of a green color. So stop, please. Kindly stop. So this is oxide of group. There is no specific group because here I have different groups. So the oxide of transition metals. Why? Because I see the green oxide with green color. Okay, so these elements when form oxide, it will form colored oxide. But group number 1, when it will form oxide, it will form white oxide. So that potassium oxide or sodium oxide, white oxides. But these elements with colored compound. Most of the transition elements form colored compounds. Most of the transition elements will form colored compounds. Transition elements can form complex ions. So chemical properties of transition metals. What are transition metals? About 30 elements in the middle of the periodic table. What about physical properties of transition elements? Like physical properties of metals: conduct heat, conduct electricity, hard, tough, strong, shiny, sonorous. Sonorous give me ringing sound, sonority. High density, good conductor of heat and electricity, malleable and ductile. And we said malleable can be drawing into different shape without cracking. Ductile can be drawn into wires, Chemical properties, they are much less reactive than group number 1 metals. Copper and nickel cannot react with cold water, but sodium can react with cold water. Copper and nickel cannot catch fire, but sodium can catch fire. And here, there is no clear trend in chemical properties, in reactivity exactly. When we talked about group number 1 metals, we said as you're going down, reactivity increase. When we talked about group number 7 non-metals, as you're going down, reactivity decrease. But here, there is no clear trend for reactivity. There is no clear trend for reactivity. Okay? Clear? There is no clear trend for reactivity. So this is when I'm talking about transition. I'm talking about transition elements. Transition elements. Let's to see what we have here. To form different colors, as you see here. Different colors. Stop, please. Kindly stop. Kindly stop making this. Jundi, Dori, Noor, Sami. Kindly stop. Okay. Uses of transition elements. Okay. The transition elements are used as a catalyst in chemical reaction. Okay, used in medicine and surgical as a jewelry, like what? Like AU, gold. Okay, this is what I need to say about transition elements. That's what I need to say about transition elements. Now we need to talk about what? We need to talk about noble gases. Noble gases. Noble gases properties and electronic structure. As you know, in noble gases, in group number 8, in noble gases, there is 8 electrons. 8 electrons. Noble gases elements which exist here: helium, neon, argon, krypton, xenon, and radon. Here, these elements are unreactive elements. These elements are unreactive elements. Okay, these elements are unreactive elements. Why? Because in outermost shell, how many electrons? As you see here, helium is exception. Helium is exception, only 2 electrons. But what about neon? How many electrons in outermost shell? 8. Argon, how many electrons in outermost shell? 8. Krypton, how many electrons? 8. Xenon, how many electrons? 8. So in outermost shell, in helium, I have 2 electrons, and this is exception. In neon, I have 8. In argon, I have 8. Krypton, 8. Xenon, 8. So what you can see here, you can see 8 electrons in outermost shell. So these elements are unreactive elements, noble gases. We call noble gases. Noble gases are in group 8 or group 0. So this is group, you can say group 8 or group 0 as well, and have very, very low melting and boiling point. Okay, that's clear because these elements are gases. So low melting and low boiling point. They are all monoatomic, colorless gases, monatomic gases. So there is no in E2. You will find in E alone. but you cannot find Cl alone. Okay, it exists as diatomic molecule to the BCl2, F2, Br2, because these elements with high reactivity, but these elements are unreactive. So you can find Ar alone, neon alone, Ne. There is no Ne2. Kr, krypton alone. They are all monatomic colorless gases. So here there is no colors. There is no specific color for helium or neon or argon. The group 0, or you can say group 8 as well, all have full outer shell, as you see here. As I said, helium is exception. Neon, how many electron? 8 electron. Argon, 8 electron. Krypton, 8 electron. Even xenon, 8 electron. So full outer shells. The electronic configuration is extremely stable. Why stable? Because in outermost shell, I have 8 electrons. So these elements are unreactive and are inert. Inert, what does it mean? It cannot make any chemical reaction because these elements are inert. Electronic configuration of noble gases, as you see here, as I said, uses of noble gases. Helium is used for filling balloon and weather balloon as it's less dense than air. Neon, argon, and xenon used advertising signs. Argon is used to provide an inert atmosphere for welding. Argon is also used to fill electric light bulbs as it's inert. So we can use argon in electric light bulbs. Why? Because argon is inert. Because argon is inert. These elements are unreactive elements. Why unreactive elements? Because have full outer shells. What does it mean for outer shells? Helium is exception because helium have only 2 electrons, but neon, argon, krypton, xenon, there are 8 electrons in outermost shell as you see here. Transition elements will form colored compounds as you see, colored compound as you see here. Transition elements are elements in the middle of the periodic table. There is no clear trend in reactivity of transition elements, but there is a clear trend in group number 1. As you go down, reactivity increase. And there is a trend in group number 7. As you go down, reactivity decrease. But there is no clear trend. There is no clear trend in the transition elements here in the middle of the periodic table. Transition elements have properties of metals, exactly properties of metals. High melting point, high boiling point, shiny, malleable. Malleable can be hammered into different shape without cracking. Ductile. Ductile can be drawn into wires. These elements are reactive, but less reactive than group number 1 metals. Less reactive than group number 1 metals. Transition elements, most of the transition elements used as catalyst in chemical reactions. Used as catalyst in chemical reaction. We can use nickel as a catalyst, iron as a catalyst, Mn as a catalyst, CO as a catalyst, Cr as a catalyst. So these elements can use as a catalyst. So that's what I need to say about transition elements and noble gases. Transition element is a block in the middle of the periodic table. Noble gases on the right column on the periodic table. You can say group 0 or group 8. These elements are unreactive elements because there are 8 electrons in outermost shell of these elements. I hope everything is clear for you. Now I'm ready to discuss with you about what I said now. Thank you for listening.